Hello again, everybody. This is the notes for area of a circle and area of a sector. So in the last section, we talked about circumference and arc length. This is the continuation. This is the second part of that packet that you got for the circumference and area of circles. So again, area of a circle, I think everybody has seen this equation before. Area equals pi times the radius squared. It's an area, so it's still a unit of length squared. So area is a length. When you square that radius, you get a unit of length squared, just times pi. So, like it says right here in red, there is a nice visualization. It's one of those GeoGebra drawings of the idea of where this formula comes from. It can get, if you really want to push it, you can kind of have a little bit of a calculus idea to it, but it's not necessary. So, if you want to check it out, it's kind of neat to see, mess with some of the numbers and some of the sliders on there. But area of a circle, pi r squared. So, as an example, find the area of the shaded region. All right. So, the biggest circle is all shaded in, with the exception of these two inner circles. All right. So, to find the area of the shaded region, we are going to take the area of the large circle minus, since there's two of these, and they are the same, we're going to minus 2 times the area of the small circle. Okay, to get the area of the large circle, pi times the radius squared. So we need to know the radius. Well, we know the radius of the little circle is 3, but what if I draw it from right here and right here? That's 3, that's 3. This is the center of the big circle. Going out to a point on the big circle, that's a radius of 6. So the radius of the large circle is 6. So the area of it is going to be pi times 6 squared, or 36 pi. When we write numbers with pi, you kind of treat it like it's a variable. And it's not a variable, but you treat it like it's a variable. So, like if we had 36x, we would write the x second. We'd write 36 and then the x. Same thing with pi. Minus, now the area of the small circle. Well, each small circle had a radius of 3, so 2 times pi times 3 squared. That's 2 times 9 pi, which is minus 18 pi. Okay, when you were adding or subtracting numbers that are dealing with pi's, again, think of it like a variable. Are they like terms? Okay, we have 36 pi's, we're taking away 18 pi's. Those are like terms. Again, it's just like 36x minus 18x. Pi is not a variable, but we treat it like it's a variable. So 36 pi minus 18 pi is 18 pi. Now, each of those radii, it was 3 meters. This is an area, so we got meters squared. Okay. Now, the next idea is an area of a sector. A sector is this yellowish green, puke green kind of color. It's like a piece of pie, essentially. To find the area of that, the logic, the thought process is exactly the same as finding the arc length. I like looking at this formula when we're just talking about finding the area of a sector. This fraction right here, this measure of arc AB, that's the number of degrees of that arc divided by the whole circle. So again, if measure of arc AB was 180 degrees out of the 360, we're looking at half the circle. So if we had a sector that was a semicircle, half the circle, and we wanted to find the area of it, we would just take half of the area of the whole circle. That's what this fraction right here is doing. If we had 50 degrees, if this angle right here was 50 degrees, we would have 50 out of the 360 degrees, and then we would have to multiply it by the area of the whole circle. So we have that fraction of the whole circle. We're just multiplying it by area now to find the area of that piece of the circle. Okay, so that's the idea of this. So defining the area of the sector. And this is how they named it, with the 3 points from a point on the circle to the center to the other point on the circle, and then the arc between them. The other equation is, just like with the arc length, it is that proportion. If your question is just what is the area of the sector, use this first formula. If it's anything else dealing with area of a sector, I would use this proportion. It becomes easier no matter what it is you were trying to solve for. All right, so let's look at this example here. We have a very weird looking ice cream cone where the center of that top is right here. So really, we have half of a circle. Now, for the cone-ish type thing, we have a right angle and we have two congruent angles. That means these are 45 degree angles. So we've got a 45, 45, 90 triangle. We know the hypotenuse. So to get to the length of one of the legs, because we need to find the area of this, you're going to divide the 7 by square root 2. And the legs are the same. So 7 over square root 2. Now that's the diameter of that circle, the half circle. So what we got, the area here, two things, is the area of the triangle. This time we're going to add on the area of the half circle. So for the area of the triangle, 1/2 the base, which is 7 over square root 2, times the height, which is also 7 over square root 2. We're going to add that to the area of that half circle. Now, it is a sector. It's just half of a sector. So what we're looking at is 180 out of the 360, that's half, times pi, times the radius, which we don't really have the radius yet. This 7 square root 2 is the diameter. That's all the way across that circle. So we need to cut that in half. 7 over square root 2, we want half of that length. So what we have is 7 over 2 square root 2. Now these are all exact values, and we'll mess with this and be able to put it in the calculator, but this is the area of this weird looking ice cream cone. Okay, some of this we don't really need a calculator for, at least not yet. For this first term, the area of the triangle, we're just multiplying 3 fractions. Go straight across. 1 times 7 is 49. In the denominator, we got 2 times the square root of 2 times the square root of 2. Well, the square root of 2 times the square root of 2 is just 2. Now multiply it by the other 2, we got 4. Plus, all right, here, the 180 over 360, that is half. I'm going to change the order a little bit. 7 over 2 root 2 times pi. So we have 49/4 plus, multiplying these first 2 fractions, 1 times 7 is 7. And we could think of this pi as over 1 if we want, so times pi over 2 times 2 is 4, square root 2, and then times 1, we don't need that times 1. Now, when we are dealing with pi, anything, whether it's circumference, arc length, area of a sector, there's 2 types of answers. This one. We were dealing with inches. This is an area, so this is inches squared. But when we leave it in terms of pi like this is the exact answer. We did not round anything. We're not cutting off any kind of decimals. This is an exact answer. On your calculator, once you start typing some numbers in your calculator and rounding, you're getting an approximate answer. So 49 divided by 4, that is 12 1/4. So as far as an approximate answer, 12.25 plus. On the calculator for the other term, 7 pi divided by, again, there's 2 parts to that denominator. You have to use parentheses. 4 times the square root of 2. Close the parenthesis for the square root, close the parenthesis for the denominator. If you don't use those parentheses, the outer parentheses for the denominator, you are going to get a wrong answer. The calculator is going to think of it as 7 pi divided by 4, taking that fraction and then multiplying the fraction by the square root of 2. We're not multiplying by the square root of 2. We're dividing by the square root of 2. That's why you need that parenthesis around the denominator. Hit enter. Now we're adding that to the 12.25. So our area approximately, squiggly equal sign, 16.14 inches squared. Okay? That's dealing with area of a circle and the area of a sector. Have a good night.